This video is from my earlier course, back when I was building out these ideas. The fundamentals I cover here are still solid, but the frameworks have evolved significantly since then. Head to systemthinkinglab.ai to see how this turned into a full course series. Hi, and welcome to our next lesson. Our lesson's titled Cultivating Senior Level Intuition. And my name is Kay Shallow. So the purpose of this course, the purpose of this lesson, is to gain access to the collective wisdom of senior engineers, to be able to understand how they think of system design end to end natively. That is the purpose of this course. It's also to distill complex concepts into practical knowledge. Again, the goal here is to give junior engineers the ability to see a system end to end from, holistically, without, let's say, knowing all of the intricate details, but to be able to have that end-to-end understanding as they do their day-to-day tasks. And also, it's to develop the intuition to approach system design challenges like experienced professional. The idea, though, is that as you are an experienced professional, when you get more and more experience, you start to notice patterns. You start to notice things that seems to recur itself in one system to the other. And the idea of this course is that can we, in some way, distill these common areas that happen over and over again? Can we teach it to you directly in a way that you can understand, so that it supercharges junior engineers' growth? And that is the purpose of this course, and this lesson is to highlight that a little bit more. So let's get into it. The journey of junior to senior engineer. The typical junior engineer, you come out of, let's say you come out of undergrad or grad school, you come out of a coding boot camp, or let's say you've studied on your own and you're able to get that higher great job. The idea here is that, hey, you know how to code. The goal is to translate clear requirements into code. Is to be the job of other more senior engineers to be able to break down tasks and break down projects into tasks that you can understand and be able to translate into code. And the more that you can do that, the more that you can continue to develop as a junior engineer. And the idea here is that as you continue to code and you see the code base and you emulate the code base and however the structure it was or however it was designed, you learn from how you code, you learn from the senior engineers around you about how to design systems. But you rarely design systems end to end when you just came in for good reason, because you're just coming in to learn and things of that nature. However, senior engineers, they architect complex systems. They're given a project or a problem that has ambiguity. The requirements may not be so well defined, and their job is to ask questions, distill those requirements, and to take that into a system design that comes that is brought forth because of their intuition from experience. That they just say, hey, they've done this before, they've seen multiple systems in a lot of different areas, and they're able to design a system end to end because of their intuition and because of their experience, because of their knowledge, the technical knowledge that they've gained over the years. So the idea is that you start off with coding, taking tasks and translating them into code. But you see, as you keep coding, you see in different code bases and different areas of the stack, you learn and you grow, and then you get to the point where you are able to architect complex systems yourself, and that's how you move from junior engineering to senior engineering. So this idea, though, that I'm describing is an apprentice model, and I find that this isn't explicitly said a lot in the industry, but if you just really drill into it, this is what's happening. The idea is that, hey, there are certain aspects of senior engineering that is, I like to say, is learned by osmosis, and system design is one of them. There are a few system design courses, and the ones they have are very complicated, very complex, talking about all the latest technologies of the moment that usually change in 2-3 years. The idea is that you just work, and you work under, one or a few senior engineers, and as you see them build and design things, you learn from them. I have a number of people that I've learned from over my 15 years of my 15-year career that I learned from and grown for. And I can give you examples upon examples of that because that's just been my experience. But this is an osmosis model. This is an apprentice model, right? That you're developing and you're looking to see how other people are doing it, and then you emulate them, and so on and so forth. There's nothing wrong with this, right? There's nothing wrong with it. Of course, mentorship, and I am the biggest proponent of this. Mentorship is a powerful way to supercharge your career growth, and you can really understand and grow and become a very solid individual in any profession that you have. So, but there is something to call out that there is a reliance on mentorship for senior engineers to be able to design systems end to end, right? And so that means that there is this sort of, I won't say a stopgap, but there is this thing that you have to overcome where in order for you to learn something, you need to find someone to emulate in order to get there. But this apprenticeship has been, of course, for thousands of years. We've had this apprenticeship concept, but I'm going to compare this apprenticeship concept to another area, and I like to have to strike the similarity here to make a point. So, because here's the limitations of the apprentice model. Because the truth is that first, you have limited access. The growth depends on the number of available senior engineers. The truth is that you can only have, every senior engineer, every experienced person can only have so many apprentices, no matter how much they can scale themselves and so on and so forth. There is a bandwidth problem here. Second is variable willingness. Like, listen, I've learned from quality senior and staff engineers that have been willing to take the time to teach me and see and show me how things are going. The truth is, though, everybody's not like that. So just because people are a senior engineer doesn't mean that they're going to be willing to be able to teach what you need to know in order to move to the next level. And then there's competency dependence, the quality of learning tied to the competency of mentors. Just because someone's a senior engineer now doesn't necessarily mean that they're qualified to be able to teach you these things, right? So the issue with the apprentice model is that there is this, with the strong reliance of mentors, in this case senior engineers, it's very dependent on their competencies, not only in their technical competencies on to do the job, but their abilities to teach or to, at the very least, emulate things that can be copied and can be readily understood by junior engineers. So I like to compare this to medical training because the medical field, especially, I'm talking about the United States here, what typically happens is that, you go to undergrad and you maybe declare yourself as pre-med and you have to take a number of classes in undergrad in order to satisfy this pre-med prerequisite. The goal is that you end up taking the MCATs, this standardized testing, this test, and then if and as you take that test, coupled with your undergraduate resume, you apply to medical school. So you have this whole school that you go to in order to become a medical doctor. Now, a good portion of medical school has real life interactions with actual patients and clients. And even after you graduate from medical school, there is residency where you continue to do that as a full-fledged doctor. However, there is this aspect of preclinical training, this idea here that you have training before you go into the day-to-day, I'm going to interact with, an actual person, even with, of course, under supervision, though, there is this training before you get to actually even facing individuals or real-life patients. And I want to hone into that. This preclinical training, they go into the basic sciences of anatomy, physiology, biochemistry, etc. I'm not an expert in this, but they go into some of the basics here, but they also go into certain practical things that, like medical ethics, how to communicate, introduction to clinical skills, how to dealing with people in the real world. But this is training.
This is school. This isn't, hey, you're in the real world, figure it out from what you see. That's not what this is. They do this for sometimes 1 to 2 years of these classes to help you learn these things. And then they move to you actually interfacing with real life clients, real life patients with under supervision. It is this part that I feel is missing. This 1 to 2 years thing, this lack of preclinical training, I think is just omitted. The idea here, and I mean, and again, we've been coding and developing for 50 years. Maybe what's happened, worked 20 years ago. Maybe that we can do a little bit better now. I think there's a gap now that there's a gap of that preclinical training. The idea is that, oh, you can code, you can write code, and you can pass the interview, check. But our systems are becoming more complex, more and more ever. It's important for everybody working into a code base to understand how it works end to end, but that is not where we are right now. New engineers are often unprepared for real challenges by design, essentially, because we take them out from these different educational areas and we have them code and just tell them, hey, we can depend on the ability for senior engineers to craft a task that is well structured so that they can just focus on that. And if they put that in the code, everything will be great. There's nothing wrong with this essentially. I just think that there's a missed opportunity that this course is focused on solving, that perhaps there is some preclinical training we can give junior engineers before they go into to the real world, or while they're in the real world, that can really supercharge their growth like we do in the medical field or in other places as well. So again, the consequence of current changing models is just that the dependence on senior engineers slows growth. Junior engineers may not grow as fast as they could be because of this dependence on senior engineering, and it assumes complex knowledge that can't be distilled into educational forms. This is the highlight of this course. I challenge that. I don't think that's true, because at the end of the day, especially if you're talking about full stack engineering, systems engineering, there's patterns that happen over and over again. No matter how many new frameworks come out, there are certain core concepts, core understandings that do not change. And once you learn those things, then you start to see all these systems in light of those things. And that's the goal of this course, that we can teach you that. And all of a sudden, you can supercharge your growth by understanding the connections between end-to-end systems you've seen before and these core concepts that we're talking about now. So now, all of a sudden, experience, so experience becomes the only teacher. Is there a way to circumvent that? That's what we're having. So the goal here, with this class, this lesson, this course, is to recognize repeated paradigms. Again, we've been programming for 50 plus years. Underlining concepts remain consistent despite new technologies. And senior engineers, any senior engineer recognizes these basic understandings and either consciously or unconsciously employ them in their day-to-day operations. So again, this course is all about a need for a new approach when it comes to system design catered to junior engineers. The goal is to accelerate junior engineers' growth and provide academic pathways to senior level intuition. This course does not necessitate you to actually be in the job. You can understand these concepts separate from it. Just like you can read a book and just like you can understand these things in an academic concept. That's the goal of this course, that you can understand these concepts. And then when you go into the real world, you can apply them, and it starts to help you to understand how different systems connect to each other, how things are similar. That is the purpose of this course, and make foundational knowledge accessible. And the pathway it is to understanding building blocks. What are building blocks? The fundamental components of system design. Understand composition, what each building block is made of, and learn integration, how to connect building blocks together to make these complex systems so that you can take an existing system or a new system, build into these building blocks, and then be able to apply current technologies that implement these building blocks that you understand so that you can build real life systems. So once again, the course objective is to encapsulate basic concepts into building blocks, provide a structured approach to system design, and help junior engineers build that senior level intuition. And the benefits of this approach is to accelerate learning, because faster growth without solely relying on experience, to independent growth, to less dependent on the availability of mentors, but the ability to empower junior engineers to understand and learn system design on their own. And adaptability, apply a foundational knowledge to new technologies. This is really key because as technologies keep going and keep changing more and more, you'll realize that the fundamental purposes and fundamental functionality of the system that you're building doesn't change. So it may just be like, ooh, there's this new technology that might implement what I really need now. But if you understand what your system actually needs and you separate that from whatever new technology you're using, all of a sudden new technologies are just opportunities to optimize your system as opposed to, oh goodness, this is a new thing. I have to change my whole architecture in order to accommodate that. So the goal is what you'll gain is practical knowledge distilled from experienced professionals, intuition to tackle system design challenges, and a solid foundation for continuous growth. So I'm really excited to bring this course with you. This is the end of the section. The next section will really talk about data and what all systems are based off. Thank you so much. Have a great day.
This was from my original course on system design for junior engineers. Since then, I've refined and expanded everything you just saw into the full system thinking the AI era course, using these same building block principles across 15 plus real case studies. If this resonated with you, the link is in the description.